Hello everyone, welcome back to Chemistry 24 into 7 series. In continuation of our Heck cross-coupling related problems, today we are going to explore one of the interesting Heck cross-coupling problems. If you are new here, don't forget to subscribe, ChemOrgChem and hit the bell icon for notification. Let's see what's today's problem. This is the question from GATE 2019. As per this question, this substrate react with palladium acetate triphenyl phosphine silver carbonate DMSO, which produce a product B, which then react with lithium aluminum hydride and followed by acetic anhydride in the presence of triethylamine, which produce a product Q. So here you can see that there are four options are given. Let's solve together to find the correct option for this question. The first reaction condition is Heck cross coupling reaction condition. We have already discussed in our channel Heck cross coupling reaction and their catalytic cycle mechanism and various examples. If anyone missed that video, you can find the link in the description box below. So as per Heck cross coupling reaction, the first step of the reaction would be a generation of active palladium catalyst generation. The active palladium catalyst for this reaction is palladium zero catalysis. So here you can see that initially palladium acetate and triphenyl phosphine here act as a ligand which react together to forms this complex, then followed by ligand dissociation which produce palladium zero catalysis. So after the generation of palladium zero catalysis, which then undergo oxidative addition with our substrate which produce this palladium complex. So after the generation of this palladium complex, which then react with silver carbonate. So when it react with silver carbonate, which produce silver iodide precipitate and followed by the generation of palladium cationic complex. So if you are familiar with Heck cross coupling reaction, you should know that two kind of mechanisms are known. One is neutral mechanism and another one is cationic mechanism. In general, cationic mechanism operates when we use silver-based additives. So here you can see that in this reaction they given silver carbonate. So therefore this reaction should undergo by cationic mechanism. So why here silver carbonate? So here you can see that this one is slightly electron rich alkene. So therefore whenever we use electron rich alkene, at the time if we use silver based additive, so those reaction should go efficiently. So as per this, so here you can see that when we interact with silver carbonate which produce a palladium cationic complex. So the next step of the reaction is pi complex formation. So now this palladium center forms the pi complex with this alkene which produce this corresponding palladium complex. So which then undergo carbopalladation. So here we need to figure out where our palladium migrate and where our aryl part going to migrate. So as per alkene electronics, so this position is slightly electron rich when compared to this position. Therefore our palladium should go with this carbon since palladium is electrophilic. Then this aryl part should go with this carbon. So resulting that produce this corresponding palladium complex. So at the same time one carbonate ion joined with our palladium center which produce this corresponding intermediate. So the next step of the reaction would be a syn beta hydride elimination. So now you can see that this is the alpha carbon. So here beta carbon as well as this carbon also beta carbon. However, this beta carbon is quaternary carbon. In case of this beta carbon has hydrogen atom. So now you can see that this green hydrogen atom perfectly aligned with this palladium center. Therefore, here syn beta hydride elimination to takes place to produce this product B along with this palladium complex. So this palladium complex further undergo reductive elimination to produce palladium zero catalysis along with the generation of bicarbonate ion. So now we successfully get the product B structure. Now this product B undergo by reduction reaction with lithium aluminum hydride. So lithium aluminum hydride is one of the powerful reducing agent which can reduce aldehyde, ketone, carboxylic acid, nitrile, and various other groups. So when it comes to the our substrate, so which is product B, so here you can see that what are the functional groups are present in this product B. So one is alkene and nitrile and another one is tosyl group. However, lithium aluminum hydride doesn't touch with alkene as well as this tosyl part. So only the reactive functional group is nitrile. So therefore lithium aluminum hydride reduce this nitrile into their corresponding amine. So after the generation of this amine, which then react with acetic anhydride in the presence of triethylamine. Acetic anhydride, one of the common acylating agent. Under basic condition, this amine acylated to produce this corresponding acylated product. So this is our product B. Well, let's move to the our question. As per our discussion, among the four answers, the correct option for this question is option C. That's it for today's problem. I hope this video has helped you to understand this question. If you enjoyed this content, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.